Look up tonight, go outside and actually look up. Not at your phone, not at a screen, at the sky. And tell me what you see. If you are in a city, you might count a dozen stars, maybe 20 on a clear night. If you are lucky enough to be somewhere remote, you might see thousands. A river of light spilling across the darkness, breathtaking, ancient, and completely, profoundly misleading. Because here is the thing nobody tells you. What you are looking at is not the universe. It is a trick, a beautiful, fragile, paper-thin trick that your atmosphere is playing on your brain. You are standing at the bottom of an ocean of gas staring up through miles of scattered photons, and your mind is stitching together this warm, populated picture of a sky full of stars, and it feels like the universe is alive with light. But strip that atmosphere away, step outside of it, float just a few hundred miles above this planet, and the first thing every single astronaut noticed, the thing they were not prepared for, the thing that changed them, was not the stars, it was the darkness between them. Not the comfortable darkness of your bedroom, not the darkness of a cinema or a long country road at nights. Something else entirely, a darkness that has weight, a darkness that feels like it is looking back. And tonight we are going to go into that darkness together. Not just describe it, not just recite facts about light and photons. We are going to understand what it actually means that space is dark, because wrapped inside that question is one of the strangest, most unsettling, most beautiful mysteries in all of physics. A mystery that touches the age of the universe, the fate of everything, the nature of matter itself, and the reason you and I exist at all. If this is the kind of journey you want to take regularly, consider subscribing. We go deep here, we go slow, and we never rush the parts that deserve to breathe. Let's begin somewhere unexpected. Let's begin not in space, but inside your eye. Right now, as you watch this, your eyes are doing something extraordinary. Your pupils are adjusting to the ambient light in the room. Millions of rod cells lining the back of your retina are firing at different rates depending on how many photons are striking them. Your visual cortex is stitching together a continuous, apparently seamless experience of reality from billions of individual light signals per second. And when the lights go low, your brain begins a process called dark adaptation. Your pupils dilate to their maximum aperture. Your rod cells, which are 10 times more sensitive to light than your cone cells, begin to dominate your vision. Chemical processes within those rods shift to amplify incoming signals. After 20 minutes in low light, you can detect a single candle flame from 17 miles away. That is not a metaphor, that is a documented measurement of human visual sensitivity. Your eyes are genuinely that powerful. And still in space, it is not enough. Not even close. When astronauts perform spacewalks on the shadowed side of the International Space Station, the engineers on the ground track exactly how long each crew member spends in darkness. Not because of cold, not because of radiation, because human vision becomes completely non-functional the moment you cross the line between sunlight and shadow. A crew member can be holding a wrench, feel it in their glove, know with absolute certainty it is there, and see nothing. Not a vague outline, not a shadow, nothing. The wrench does not exist to their visual system. That is how dark the shadow side of a spacecraft in Earth orbit is, and we have not even left the solar system yet. Here is a question that seems obvious until you really think about it. Why is space dark at all? You might say because there are no light sources nearby, but that cannot be right. The sun is right there, 8 light minutes away. An object so luminous that looking directly at it will blind you within seconds. The sun outputs more energy every single second than humanity has consumed in all of recorded history combined. It is flooding the solar system with photons in every direction constantly. They are passing through you right now, trillions of them per second. So why, if you floated in open space between Earth and Mars, would you be surrounded by near-perfect darkness the moment you turned away from the sun? Because you are not made of air. Light does not illuminate space, it illuminates things in space. This is one of those facts that sounds obvious, but actually breaks your brain when you sit with it. On Earth, you experience light as something ambient. You walk into a room and the room is bright. That is because the air is full of microscopic particles, dust, humidity, gas molecules, and photons scatter off all of them and bounce in every direction. Your entire visual experience on Earth is built on scattered light. You are not seeing sources of light most of the time. You are seeing things that have been hit by light. The blue sky above you right now is not blue because space is blue. It is blue because nitrogen molecules in the atmosphere scatter short blue wavelengths of sunlight in every direction, and you are immersed in that scattered glow. Remove the atmosphere and the sky above Earth would be as black as the sky above the moon, which is black during the day while the sun blazes overhead. Black sky, bright sun at the same time, because there is nothing for the sunlight to scatter off of. So imagine the empty expanse of space. Photons from the sun, from distant stars, from galaxies billions of light years away, they are all traveling through that space right now. Streams of light crisscrossing in every direction, and yet if you float in that space and turn away from all those sources, you see these nothing, because a photon in transit is invisible. It only becomes visible when it stops, when it ends its journey in the photoreceptor of an eye or on the surface of a detector. The universe is threaded with rivers of light, and if you are not standing at the mouth of one of those rivers, pointing exactly at a source, you see only the dark. This is genuinely one of the strangest facts in physics. You can be bathed in light and be in total darkness simultaneously. Astronauts working outside the ISS on the sunlit side will turn their helmets a few degrees in the wrong direction and instantly lose sight of a tool they were looking at, not because the tool moved into shadow, because their eyes moved away from the angle at which sunlight was reflecting off it. The sun is right there, the tool is right there, and yet darkness. This is not how your brain expects light to behave. Your brain was built for a planet wrapped in a light-scattering blanket of gas. Space operates by completely different rules, and this goes deeper, much deeper. At some point tonight, you are probably going to close your eyes and drift towards sleep. And what will you experience as you do? You will experience something you probably call darkness, but it is not really darkness at all. Close your eyes right now for just a moment. What you see is not blackness. It is a rich, shifting, subtly luminous field, faint colors, moving patterns, the visual noise of a brain that is still firing, still generating a visual world even with zero input. Your visual cortex does not go quiet in the dark. It fills the silence with itself. This phenomenon has a name, Eigengrau, from the German for intrinsic gray. It is the color your brain creates when it has no photons to work with. Even in total darkness, even in a perfectly light-proof room, you are not seeing nothing. You are seeing the hum of your own nervous system. Now imagine your visual cortex receiving exactly zero signal. Not quiet signal, not reduced signal. Zero, the kind of zero that exists in the spaces between galaxies. The intergalactic void is not merely dark in the way we normally use that word. It represents a physical state that has no equivalent anywhere in human experience. The density of matter in intergalactic space is approximately 1 atom per cubic meter. One single atom rattling around in a volume the size of a large refrigerator. By comparison, the air you're breathing right now contains roughly 27 quintillion atoms per cubic centimeter. The vacuum chambers in our most advanced physics laboratories, the best we can build, cannot come close to the emptiness that exists naturally in the void between galaxies. We cannot manufacture the emptiness of space. It is beyond our technological capability. And in that emptiness, there is nothing for light to interact with, nothing for photons to scatter off, nothing for your eyes to receive signals from. If you were suspended in the center of the Buddha's void, a vast, nearly empty region of space, roughly 330 million light years across, the nearest galaxies would be hundreds of millions of light years away in every direction. You would see faint smudges of galactic light in some directions. But between you and those smudges, stretching for incomprehensible distances, absolutely nothing. Your eyes would strain with everything they have, those magnificently evolved organs capable of detecting single photons, and they would find nothing to detect. Not because the photons are not there. Some are passing through you right now from those distant galaxies, but none are arriving at the angle, with the density, with the wavelength your eyes can use. You would be blind, not metaphorically blind, literally unable to see anything in any direction you turned. And here is where it gets philosophically unsettling, because that darkness would not be empty. The universe is full of things we cannot see. This is not a New Age concept or a spiritual claim. It is hard experimental physics backed by a century of observations. What we call visible matter, everything you have ever seen with your eyes or in any photograph ever taken, the stars, the galaxies, the nebulae, the planets, the gas clouds, All of it combined accounts for approximately 5% of the total mass and energy content of the universe. 5%. The other 95% is invisible to us, not because our technology is not good enough, but because it does not interact with light in any way we can detect. It does not emit light. It does not absorb light. It does not reflect light. It is not made of the same stuff you are made of. About 27% of the universe is what we call dark matter. We know it is there because of gravity. It bends light from distant sources. It holds galaxies together in ways that the visible matter alone cannot explain. Our own Milky Way would fly apart if it were only held together by the gravitational pull of its visible stars. Something else is there, something with mass, something exerting gravitational force on everything around it, and it is everywhere. Right now, dark matter is streaming through your body at roughly 200 kilometers per second. Hundreds of billions of dark matter particles passing through you every second, and you feel nothing, and you can see nothing, and nothing detects them except the most sensitive instruments we have ever built, and even those only catch the rarest of interactions. The remaining 68% of the universe is even stranger. We call it dark energy, and we have almost no idea what it is. What we know is this: the universe is not just expanding, it is expanding faster and faster. Galaxies are accelerating away from each other. Something is driving that acceleration. Something embedded in the fabric of space itself is pushing everything apart, counteracting gravity on the largest scales, and it is completely invisible. It has no color, no mass in the conventional sense, no detectable electromagnetic signature. It is the dominant substance in the universe, and we cannot sense it in any way. So when you look out into the darkness of space, you are not looking at emptiness. You are looking at a universe that is 95% invisible to you. The darkness is not nothing. The darkness is full of things your biology simply cannot access. You are in a box with no windows, convinced you understand the room. Take a moment to let that settle. And if you are finding these deep dives as fascinating as we do, hitting that like button genuinely helps us reach more people who are searching for exactly this kind of content. It costs you nothing, and it means everything to us. Now, let's talk about something that is genuinely one of the most beautiful paradoxes in the history of science. Because the darkness itself, the very fact that the night sky is black instead of brilliantly white, is one of the most powerful pieces of evidence we have about the nature of the universe. This is called Olbers Paradox, and it is 200 years old, and it still stops physicists cold when they really think about it. The setup is this: if the universe is infinite, and if it is filled with stars evenly distributed through that infinite space, then every single line of sight you cast from your eye should eventually end at the surface of a star. Not eventually in the far future. Every line of sight right now. An infinite universe full of stars means infinite stars in every direction, and if you add up the light from infinite stars, you do not get a gentle glow. You get a sky as bright as the surface of an average star. A sky that would blaze with the same luminosity as the face of the sun in every direction at every moment. You would not survive it. Nothing would. And yet, the sky is dark. For most of history, this was dismissed or ignored. It seemed like a philosophical curiosity. Then, in the 20th century, we figured out the answer. And the answer rewrote everything we thought we knew about the universe. The universe is not infinite in time. It had a beginning. Approximately 13.8 billion years ago, something happened. Space, time, energy, matter came into existence. We call it the Big Bang. And because the universe has a finite age, light has a finite time to travel. 13.8 billion years of travel time means we can only receive light from objects within a sphere approximately 13.8 billion light years in radius. Beyond that boundary, light has not had time to reach us yet. There are almost certainly stars beyond that horizon, galaxies, perhaps civilizations, but their light is still on its way, will not arrive here for billions of years, and so those stars do not contribute to the brightness of our sky. But wait, that alone does not fully explain the darkness, because even within our observable universe there are trillions of galaxies, each containing hundreds of billions of stars. Should not the combined light of all of them still be quite bright? And this is where the expansion of the universe enters the picture. The universe is not just expanding. It is expanding such that the light from the most distant sources is stretched. As those photons travel toward us, the space they are traveling through stretches and the wavelengths of those photons stretch with it. Light that left a distant galaxy as visible light arrives here as infrared, or microwave, or radio waves. Wavelengths completely invisible to your eyes. All that light is still arriving, streaming through you right now from the most ancient sources in the universe. But your eyes cannot see it. It is outside your range, and so it does not brighten your sky. The night sky is dark because the universe is young, because it had a beginning, because it is expanding. The darkness above you every night is not nothing. It is the signature of cosmology itself written in the language of absence. Every time you look up at a dark night sky, you are looking at direct observational evidence that the universe was born 13.8 billion years ago and is still racing outward from that moment. That is not poetic, that is physics. Now let's travel. Let's go somewhere no human has ever been and experience what this darkness actually means on a human scale. You are in interstellar space, not near Earth, not near any planet. You are in the void between star systems, roughly halfway between our Sun and the nearest stellar neighbor, 2.5 light years from the closest light source in any direction. The Sun behind you is visible, bright, the brightest star in your sky by far, but it is a point, a very bright point, but a point, a blazing dot in an otherwise dark field. It is not illuminating anything around you. There are no surfaces nearby for it to illuminate. There is no air for its light to scatter through. You float in vacuum so complete it makes our best laboratory chambers look dense. In every direction except directly at the Sun, darkness. Not the comfortable darkness of a room with the lights off. Not even the dramatic darkness of a moonless night far from cities, something qualitatively different. A darkness your visual system has no category for. Your rod cells, adapted to detect single photons, are sweeping across a sky with no photons to find except from stars so distant they arrive one at a time. You see points of light, thousands of them, beautiful, but between them, and they are not close together, the gaps between even neighboring stars are enormous in terms of visual angle. The darkness is absolute. Your eyes move across it and report nothing. No gradient, no texture, no faint illumination of anything nearby. Nothing to tell you where up is. Nothing to tell you how far you have moved or whether you have moved at all. The darkness does not just surround you. It removes reference. It dissolves orientation. It takes away the context that your nervous system uses to construct the experience of being somewhere. Astronauts who have described floating in shadow during spacewalks talk about a primal response. Not panic exactly, something older and quieter than panic. A deep biological alarm that has nothing to do with conscious thought. Your nervous system was built over millions of years on a planet where complete darkness meant extreme vulnerability, where the inability to see meant predators could approach unseen, meant you could walk off a cliff, meant you were alone and exposed in a world full of things that wanted to eat you. That alarm system does not care that you are in a spacesuit tethered to a spacecraft. It does not respond to intellectual reassurance. It fires regardless. It fires because it is honest. The darkness of space is unlike anything your ancestors ever encountered. It is a darkness so complete and so vast that the biological response to it is genuinely, accurately, appropriately one of awe and alarm. Some of the most respected astronauts and cosmonauts in history have described looking away from Earth into deep space and feeling something shift inside them. Not a clinical observation, but an emotional reckoning. A visceral understanding of scale that photographs and textbooks cannot produce. Krista McAuliffe, preparing for what would have been her mission, described reading accounts of astronauts looking into the deep void and feeling something she called productive terror, a fear that was also somehow clarifying. The darkness was not an enemy. It was a fact, the biggest fact there is. And here is something the competitor scripts always seem to miss, the thing the comment sections are quietly asking about, the part of this story that is not about terror but about something more interesting than terror. The darkness is not the same everywhere. There is a hierarchy, a taxonomy of dark, and moving down that hierarchy reveals something about the structure of the universe that is almost musical in its logic. The first level of darkness is the shadow dark, the darkness on the shadowed side of an object in space. This is the dark of the lunar night, the dark side of an asteroid, the shadow of a spacecraft. This darkness is real, complete, absolute, the kind that makes astronauts disappear to their crewmates in an instant. But it is local. You are in shadow because a nearby object is blocking a light source that exists. Move 100 meters and you step back into sunlight. This darkness has a geometry, an address. The second level is the interplanetary dark, the darkness of empty space within our solar system, away from the sun and away from any planet. Here the sun still blazes. It is still the brightest object in your sky by an enormous margin, but it provides no ambient illumination because there is nothing ambient. You are in sunlight and in darkness simultaneously. One side of you bakes, the other side plunges to nearly minus 270 degrees. The sun illuminates what it strikes directly and nothing else. The third level is the interstellar dark, the darkness between solar systems. Out here the sun is just another star. Bright, yes, easily identifiable against the field, but unable to light anything around you. The nearest stars are years of travel away at the speed of light. The density of matter drops to approximately 1 atom per cubic centimeter, a vacuum so profound it has no earthly equivalent. Here the darkness is not just the absence of artificial light or reflected light. It is the absence of any meaningful illumination at all. The fourth level is the intergalactic dark, the void between galaxies. Out here the density of matter drops by another factor of 1,000,000, 1 atom per cubic meter. Our entire Milky Way visible as a faint smudge if you look in the right direction. Andromeda, another smudge 2.5 million light years away. And in every other direction, emptiness stretching for hundreds of millions of light years. The darkness here is so complete, so uniform, so featureless that the human visual system would literally have nothing to process. You could stay out there for days and your eyes would not adapt. There is nothing to adapt to. The signal is zero. And then there is the fifth level, the one that lives not in space but inside physics itself, the interior of a black hole. A black hole is a region where space-time has curved so severely that the escape velocity exceeds the speed of light. Nothing that crosses the event horizon can ever return, not information, not light, not any signal of any kind. To the side universe, anything that falls past the event horizon has simply ceased to exist. The light it emits on the way in is stretched and dimmed towards zero. The object appears to slow and freeze and redden and fade at the horizon but never quite disappears. But from inside the horizon, everything is different. Inside a black hole, you are in a kind of darkness that has no analog anywhere else in physics. It is not just that no light reaches you from outside. It is that the structure of space-time itself prevents the formation of paths that light could travel to reach you. The darkness is not situational. It is geometric. It is baked into the shape of space itself. Photons from outside cannot reach you, not because they are blocked, but because there is no path for them to travel. This is the darkest thing in the universe, a place where the concept of being illuminated by something has become geometrically impossible. We have now photographed black holes. In 2019, the Event Horizon Telescope collaboration released the first image of the supermassive black hole at the center of the M87 galaxy. A bright glowing ring of superheated plasma orbiting something that appears in the image as a circular shadow. That shadow is not a shadow in the usual sense. It is the hole itself, the place where light goes and does not come back. And surrounding that perfect circle of darkness is the brightest thing in the visible image, gas heated to billions of degrees, shrieking as it falls inward. Brightness and the most absolute darkness that exists side by side, separated by a boundary you could cross without feeling anything unusual, without any physical sensation of transition, and then gone. We're about 2/3 of the way through our journey tonight, and if you have stayed with us this long, you are clearly someone who does not just want the highlight reel, you want the whole story. We spend a lot of time crafting these scripts to be worth your 2 hours. If you want to support that work more directly, our Patreon is where we go deeper, longer, and into territory that would not survive on YouTube alone. The link is in the description. But for now, let's keep going. Because we have been talking about darkness as a physical condition. Now let's talk about what it does to the mind. This is the part that rarely gets the treatment it deserves. Most scripts on this topic treat the psychological dimension as a footnote. A few lines about astronauts feeling lonely, a mention of sensory deprivation, and then back to the physics. But the psychological reality of darkness, the way complete visual deprivation interacts with a human nervous system, is one of the most strange and illuminating areas of science we have. Start with what happens to vision in complete darkness over time. The first 20 minutes in a perfectly dark room are characterized by adaptation. Your pupils dilating, your rod cells activating, your visual cortex quieting its daytime chatter and beginning to listen for faint signals. By 30 minutes, your vision has reached its maximum biological sensitivity. You can detect individual photons under ideal conditions. Your brain is straining to find patterns in the noise. After an hour, something different begins to happen. In the absence of real visual signals, the brain, which is fundamentally a prediction machine, starts generating its own. Faint phosphenes begin to appear, geometric patterns that seem to drift and shift, points of light that have no source, colors that appear at the periphery of your visual field. These are not hallucinations in the clinical psychiatric sense. They are what happens when a sensory system optimized for signal processing finds no signal. It begins to process itself. The visual cortex begins to respond to its own background activity, as if it were input. You start seeing what your brain sounds like. Extended the darkness over days and the effects become more profound. Studies of individuals spending extended periods in complete darkness show that after approximately 48 hours, the visual cortex begins responding to non-visual inputs. Sounds begin to generate visual processing activity. Touch begins to activate regions normally dedicated to sight. The brain, denied its primary input channel, begins reassigning those enormous processing resources to other senses. You begin to hear and feel with new clarity and intensity. A compensation mechanism, automatic and biological. Coming back to light after extended darkness is disorienting in ways that go beyond simple sensitivity to brightness. The visual system has reorganized. The sudden return of rich visual input can be overwhelming. People report difficulty processing visual scenes that previously seemed simple. A crowded room, a busy street, too much information arriving too fast for a system that has reallocated some of its capacity elsewhere. Imagine this in the context of a crew on a multi-year interstellar voyage. Not in complete darkness, of course, the spacecraft has lights. But through every window, in every moment of downtime, in every unoccupied visual moment, darkness. The same darkness, unchanging. The same arrangement of distant static stars that barely move over the course of years. The visual system evolved for a dynamic world of shifting light and color and movement and depth. A world where the visual scene changes constantly, where there is always new information to process, always new threats to assess or resources to locate. Put that system in an environment of near-perfect visual monotony, and it begins to create its own variety. The stars outside the window begin to seem to shift. Patterns emerge in the void. Faces appear in darkness. The mind, unable to stop doing what it does, generates its own content from nothing. This is not speculation. Submarine crews on long deployments, deep cave explorers, polar winter researchers, they all report variations of the same experience. The mind makes things up, not because something is wrong with it, because something is right with it. It is doing exactly what it evolved to do. It is searching for patterns in limited data and generating predictions about a visual world that barely exists. The darkness does not empty the mind, it fills it with itself. And this brings us to something that sits at the intersection of neuroscience, philosophy, and physics that I find genuinely one of the most strange and underappreciated ideas in all of science. You have never actually seen anything. Stay with me here. What you experience as vision is not a direct recording of the external world. Your eyes are not cameras sending images to a screen inside your head. They are transducers. They convert photons into electrical signals. Those signals travel down the optic nerve, get processed through multiple layers of neural computation, get combined with information from memory and expectation and emotion, and then your brain generates what neuroscientists call a model, an internal simulation of a possible external world that would be consistent with the signals your eyes are sending. You experience that model as sight, but you are not seeing the world. You are seeing your brain's prediction of the world, continuously updated by incoming sensory data. In normal circumstances on Earth, this distinction is academic. The model is good enough. It matches the world well enough to navigate and survive. But in the darkness of space, where the incoming data drops to near zero, the model does not shut off. It cannot. Your brain does not have an off switch for reality generation. It keeps running. It keeps predicting. And with no sensory data to anchor it, The predictions drift free of the world. You experience things that are not there. You experience the texture of your own nervous system masquerading as external reality. This is one reason why extended isolation in low-stimulation environments is psychologically challenging in ways that cold or hunger or physical danger are not. Cold and hunger have solutions. More calories, more insulation. But the darkness of the mind meeting the darkness of space is a different kind of problem. It is the fundamental architecture of human consciousness, encountering an environment it was not built for. And the response is not breakdown, not usually. The response is transformation. The mind finds a way. It always finds a way. But the way it finds may be strange. Some of the most creative and philosophically profound accounts in the history of exploration come from people who spent extended time in environments of extreme sensory poverty. Long solo ocean voyages, polar explorers, deep cave researchers, they describe not a degradation of mental life but a strange intensification. The internal world becomes vivid. Memories surface with unusual clarity. Thoughts that never had room to fully form in the noise of daily life arrive complete and fully realized. The darkness for some people is not a loss. It is an excavation. This brings us to the question of what the darkness means. Not physically, not neurologically, but what it means in the way that things mean something to a person sitting with their eyes open in the dark. The universe has been dark for most of its existence. In the very beginning, in the first few 100,000 years after the Big Bang, the universe was opaque. Too hot, too dense, photons bouncing off particles in every direction, unable to travel more than a tiny distance before being absorbed. The early universe was a bright, blazing plasma fog, but light could not travel through it, which is the same functionally as darkness from an information perspective. There were no observers, and there was no clear path for light to reach any observer if one existed. Then, at approximately 380,000 years after the Big Bang, the universe cooled enough for electrons and protons to combine into neutral hydrogen. In a geological instant, cosmologically speaking, the fog cleared. Photons could suddenly travel freely. Space became transparent. And the light that had been trapped in that fog was released into the universe. That light is still traveling. It fills space in every direction right now. It is called the cosmic microwave background radiation, and it is a photograph of the universe at 380,000 years old. A perfect sphere of ancient light surrounding us in every direction, invisible to your eyes because it has been stretched by 13.8 billion years of cosmic expansion into microwave wavelengths. But it is there. Every point in space is bathed in this ancient light. The universe's baby picture, written in wavelengths you will never see. After that moment of cosmic clearing came the Dark Ages, not metaphorically, actually, cosmically, the Dark Ages. For hundreds of millions of years after the plasma cleared, there were no stars. The neutral hydrogen and helium gas drifted and clumped under gravity, but had not yet reached sufficient density to ignite nuclear fusion. The universe was transparent but dark, full of matter, full of ancient photons cooling toward invisibility but producing no new light, no stars, no galaxies, just clouds of gas drifting in the expanding dark. Then the first stars formed, and that, on the cosmic timeline, was one of the most dramatic events in the history of everything. The first light in a universe that had been dark for 300 million years. Massive objects, hundreds of times the mass of our sun, burning through their fuel in just a few million years before exploding as supernovae and seeding the surrounding gas with the heavy elements that would eventually become planets. And you, the carbon in your body was forged in a star that died before our sun existed. The iron in your blood was produced in a supernova explosion. The oxygen you are breathing was generated in stellar interiors and distributed through cosmic space by those same explosions. You are not a visitor to the universe. You are a product of its chemistry. A temporary arrangement of material that was forged in the darkness between the first stars and distributed by the violence of their deaths. When you look at the darkness of space, you are looking at the medium that created you. We are now in the era of maximum stellar activity. The universe is at roughly middle age in terms of star formation. Stars are burning in their hundreds of billions across trillions of galaxies. This is the bright era. This is the era of light, and it will not last forever. Star formation peaked approximately 10 billion years ago. It has been declining ever since. The available hydrogen gas, the fuel for star formation, is being consumed and not replaced at the same rate. Slowly, over hundreds of billions of years, the rate of new star birth will fall. Existing stars will age and die. The most massive will explode and leave behind neutron stars and black holes. Medium mass stars like our Sun will swell into red giants before collapsing into white dwarfs. Small red dwarf stars will burn slowly for trillions of years before dimming. In approximately 100 trillion years, the last star will go out. Not with a bang, just a slow dimming. A red dwarf cooling through orange to yellow to white to grey to black. And the universe will enter a new dark age. Not like the dark age after the Big Bang, which had the potential energy of hydrogen waiting to be ignited. This dark age will be different. The fuel will be gone. The light will be over. What remains will be the cooling remnants. Black holes slowly evaporating over timescales that make the current age of the universe seem like an afternoon. The mathematics of Hawking radiation suggests that a black hole the mass of our Sun would take approximately 10 to the power of 67 years to evaporate completely. A supermassive black hole at the center of a galaxy would take approximately 10 to the power of 100 years. Numbers so large they are effectively meaningless in human terms, but finite. They will end. They will evaporate. They will release their last slow trickle of radiation into a universe of expanding nothing. After that, after 10 to the power of 100 years, the universe will contain photons, scattered cold separated by distances that grow as space continues to expand. No matter, no structure, no gradients of energy that could drive any process. Perfect equilibrium, perfect darkness, eternal. This is the far future that physics predicts, and here is the thing that I find profound rather than bleak about it. We are not near that end. We are not even near the middle. We exist in the first few moments of the universe's narrative. The universe is 13.8 billion years old. The era of stars will continue for another 100 trillion years. We have barely started. We are living in the bright dawn of a cosmos that has most of its story still ahead of it. The darkness at the end is so far away it is meaningless as anything other than a fact about physics. What is not meaningless, what is immediate and real and present, is that we are here in the bright era, on a warm planet orbiting a middle-aged star, with the ability to look up and ask why the sky is dark. Not all arrangements of matter can do that. Most cannot. Most never will. That ability is not nothing. That is, in fact, the most extraordinary thing in the observable universe. If you are enjoying this journey and want to help us keep making content like this, our Patreon supports everything from longer scripts to deeper research to a community of people who care about exactly these questions. Find it in the description. Even a small amount of support makes an enormous difference to a channel of our size. Now, let's come back to Earth. Or rather, to where we are going, because the darkness of space is not just a scientific curiosity. It is the environment that human civilization is preparing to inhabit. Within the lifetime of people alive today, human beings will stand on the surface of Mars. They will look up at a sky that is not black but close. The Martian atmosphere, thin as paper compared to Earth's, scatters just enough light during the day to create a pinkish tan sky, but after sunset it drops to black almost immediately. No twilight worth the name. No gradual deepening of blue to violet to black that you watch from Earth, just light and then dark, clean and immediate, and then two moons, barely larger than bright stars, crossing the sky. Those first humans on Mars will experience darkness differently than we do here. The night sky from Mars, without our atmosphere to blur and scatter the stars, will be sharper and denser and more immediate than anything you can see from Earth's surface. The Milky Way will be visible on every clear night as a dense river of individual stars rather than a blur. Satellites and other human spacecraft will be identifiable. The sky will be a continuous connection to the universe in a way that you almost never experience from the bottom of our atmosphere. But outside the habitat, in the Martian night, the darkness will be the darkness of a world without electricity and without the thick light-scattering air you rely on. Rover headlights carving narrow cones of visibility in an otherwise absolute dark. Any human working outside in the Martian night without lights would be functionally blind instantly. And this raises a question that future mission planners are already working on. How do you design for the psychological impact of darkness on multi-year missions? not just the physical challenge of working in low visibility conditions, but the cognitive and emotional challenge of spending years in environments where the default visual state is darkness interrupted by artificial light rather than sunlight filtered through a welcoming atmosphere. The studies that feed into this design work come from unusual places. From Antarctic winter station researchers who spend months in polar darkness. From submarine crews who live without natural light for months at a stretch. From individuals in long-duration isolation simulations. The consistent finding is that access to views, even views of darkness and stars rather than Earth's blue sky, matters significantly to psychological well-being. Closing off the windows does not help. People prefer to see the darkness, to look into it, to feel oriented within it, rather than to have it hidden from them. This is counterintuitive. You might expect that blocking the view of the void would reduce its psychological weight. Instead, it appears to increase it. The darkness is more threatening when it is hidden than when it is visible. When you can see it, even if what you see is only stars and the void between them, your brain has something to process. You have visual information, you are oriented, you know where the darkness is. When the windows are blocked, the darkness is still there, but now it is also unknown. It surrounds you on all sides without shape or feature, and that formlessness is its own kind of weight. Humans need to look at the universe. We always have. Every culture in human history, across every continent, in every time period we have any record of, has looked at the night sky and found meaning there. Stories, navigation, religion, science, art. The sky is the oldest thing humans have looked at together. It connected nomadic bands of hunter-gatherers who would never meet. It gave sailors their position on trackless oceans. It gave farmers their calendar. It gave everyone, in every era, the visceral knowledge that they were small in a very large story. Electric light has largely stolen that sky from us. 80% of humanity now lives under light-polluted skies. In North America and Western Europe, the number is over 95%. Most children alive today will never see the Milky Way unless they travel specifically to find dark skies. The story written in stars above us every night, the oldest story, is being drowned in the glow of our own civilization. This is not a minor aesthetic loss. It is a severance from something that shaped human cognition for hundreds of thousands of years. The absence of stars, the daily evidence of our smallness and our connection to something vast and ancient and ongoing, this matters in ways that are subtle and persistent and accumulating. It affects how we think about time, about scale, about what is worth worrying about. Standing under a truly dark sky forces a recalibration that no screen can replicate. It makes certain problems feel smaller, certain possibilities feel larger, certain assumptions about what matters feel suddenly questionable. There is a reason that the most significant moments of philosophical insight in many traditions are associated with wilderness and night skies, not sentiment, not superstition. Something neurological and real about removing the scaffolding of civilization and standing under the full weight of the universe. The darkness, in this sense, is not the enemy of meaning. It is the context in which meaning becomes visible. And now let me bring you to the final thing I want to sit with tonight. Something that the physics and the psychology and the history of exploration all point toward, and that does not get said enough. The darkness is where we came from. Life on Earth began in darkness. Deep ocean vents, kilometers below the surface where no sunlight has ever reached, are among the most probable locations for the origin of life. Chemical reactions driven by the heat of the Earth's interior rather than the light of the sun. The first living systems, whatever they were, emerged in darkness and learned to extract energy from chemistry before any of their descendants figured out how to harvest light. Photosynthesis was a later innovation, a brilliant one that remade the planet, but a later one. We are the descendants of organisms that were born in the dark. The elements that make up your body were forged in the cores of stars that lived and died in the darkness of space before our sun ignited. The Earth formed from the debris of those deaths, coalescing in the early solar system from dust and gas that drifted in the dark for millions of years before gravity pulled it together. The oceans that host the origin of life arrived here partly from comets, dark bodies wandering the outer solar system for billions of years before their orbits brought them inward. The darkness is not something we are exploring. It is something we have come back to. We grew up in it. We are made of it. The light, our star, our civilization, our brief illuminated era in cosmic history, these are the exception. They are what happens when matter arranges itself into the right configurations for a few billion years in a universe that is mostly and permanently dark. There is a word for this kind of relationship between light and darkness, between the brief and the vast, between what we are and what the universe mostly is. The word is humility, not the false humility of self-deprecation, not the crushing humility of meaninglessness, but the clean, spacious humility of accurate scale. The humility of standing in the right relationship to a universe that is old and vast and mostly dark and does not care about you specifically, but that produced you anyway, and that through your consciousness and your curiosity has managed to look at itself and wonder why it is so dark. That wondering, that specific act of a temporary arrangement of matter, looking at the darkness that produced it and asking what the darkness is and what it means. That is not small. That might be the largest thing happening in the observable universe right now. The darkness of space is terrifying if you stand on the outside of it and look in. But we are not on the outside. We are inside it. We are made of it. We are the universe's way of looking at itself and feeling the appropriate combination of awe and vertigo and the strange, specific comfort of finally understanding where you are. It is dark out there. It is dark almost everywhere, and that is exactly right. And you are a temporary arrangement of the same atoms that have drifted through that darkness for billions of years, briefly illuminated, briefly conscious, briefly capable of knowing that the darkness exists and what it means. Before we get to that final resting place tonight, let me take you somewhere that almost no other script about darkness bothers to go. But there is a tradition in physics and philosophy, a serious one backed by rigorous thinking, that suggests the separation is not as clean as we assume. Consider what observation means in quantum mechanics. At the scale of individual particles, matter does not behave the way large objects do. Electrons and photons and protons do not have definite positions and velocities the way a billiard ball does. They exist in what physicists call superpositions, states of simultaneous possibility that only resolve into a single definite outcome when they interact with a measuring device, or more controversially, when they are observed. The famous double-slit experiment demonstrates this in the most direct way possible. You fire individual photons at a barrier with two narrow slits cut into it. If you do not observe which slit each photon passes through, the photon behaves as if it passes through both slits simultaneously. It interferes with itself on the other side and produces a wave-like interference pattern. But if you set up a detector to observe which slit the photon passes through, the interference pattern disappears instantly. The photon now behaves like a particle. It went through one slit or the other. The act of observation changed the outcome. This has been verified in thousands of experiments across many decades. It is not controversial among physicists. What is controversial is what it means. What exactly is happening when an unobserved photon exists in superposition? Where does that superposition go when observation collapses it? What does it mean that the act of looking at something changes what it is? One interpretation, the many worlds interpretation, suggests that every quantum event that could go either way does go both ways. The universe splits. In one branch, the photon went left. In another branch, it went right. Every quantum measurement, every interaction that has two possible outcomes generates a new branch of reality. The universe is constantly and relentlessly bifurcating into an exponentially growing number of parallel versions of itself, all equally real, none aware of the others. In this picture, the darkness of space is even stranger, because the empty vacuum of space is not empty. It is a seething background of quantum superpositions, virtual particles appearing and annihilating, fields fluctuating. The vacuum itself is in a constant state of quantum activity that only appears calm and empty because you are looking at it at the wrong scale. The darkness is, in a sense, made of possibility, potential states not yet collapsed by observation, a universe holding its breath,